What if everyone on Earth turned on a flashlight and pointed it at the sky? Well,
This question comes from Marcus, who asks, a typical flashlight puts out somewhere between 50 and 200 lumens. There are about 8 billion people on Earth. So even if we hand every single person a reasonably decent flashlight and aim them all straight up on the same night, we're looking at a combined output of somewhere around a quadrillion lumens. That sounds impressive until you realize the sun alone delivers about 3.6 times 10 to the 28th lumens. That makes our collective flashlight effort look like someone struck a match next to a nuclear explosion. Here's the immediate problem though. We need everyone pointing at the same patch of sky at the same time. That means we need it to be night for everyone simultaneously, which is not how Earth works. We'd have to cram the entire human population into roughly one hemisphere. Let's say we wait for the right conditions, spread people across the night side. Assume everyone has a flashlight that produces a focused enough beam to actually matter. Here's what happens. A faint, diffuse glow that no instrument in orbit would even bother flagging. What if we increase the power output? Let's give everyone a proper tactical flashlight, the kind that costs $80, runs on a lithium battery, claims 1000 lumens in a tight beam. At this output level, our combined beam energy starts to get genuinely interesting. If we could focus all 8 trillion lumens into a coherent beam aimed at, say, the International Space Station, the astronauts inside would be treated to something roughly as bright as a partly cloudy afternoon. So keeping it illuminated would require approximately perfect timing from every person alive. What if we boosted the intensity further? We'd need to abandon flashlights entirely and give everyone a military-grade xenon spotlight, the kind mounted on naval search vessels. 500 watts and roughly 40,000 lumens per unit. The combined output of 8 billion of these is now around 320 quadrillion lumens. Aimed collectively at the moon, we'd be delivering a measurable fraction of extra illumination to the lunar surface. But enough that a sensitive photometer in orbit would definitely register something unusual happening. We're making progress. What if we amplified it even further? Let's give everyone an IMAX projector lamp, focused and filtered. Assume we've solved the minor logistical challenge of keeping 8 billion water-cooled bulbs running simultaneously. Our collective beam is now bright enough that the moon's night side would visibly brighten for anyone watching through even a modest backyard telescope. The power draw, however, would be roughly 4 times the total electricity currently generated on Earth. So within about 90 seconds, we would experience a global blackout of historic proportions, every grid on every continent collapsing at once. The whole experiment would end in darkness, which is a fairly ironic outcome for a flashlight question.
did you like the video? Click like and subscribe if you'd like to see more.